Okay, let's jump right into today's explainer. We're diving into the invisible layer of computing that directs literally every single piece of data you send. Whether you're clicking a file, typing in a web address, or just asking your smart speaker to set a pizza timer, there's this hidden traffic cop working overtime behind the scenes. Today, we're going to figure out exactly what a router is and why understanding this one concept will completely change how you look at everyday software. So, think about this for a second. When you fire off a command, how on earth does your computer actually know what to do with it? I mean, raw data is just a messy jumble of bytes and characters, right? It has no inherent meaning on its own. So how do those raw inputs magically find their way through these massively complex systems to become the actual actions you wanted? Well, that is exactly where our hidden traffic cop comes in. To answer that, here's our quick roadmap. We'll look at the hidden decision maker, a restaurant analogy, how a router actually works, common routing signals, and finally, what happens when routing goes wrong. Let's kick things off with section 1, the hidden decision maker. So what exactly is a router? At its core, a router is just a decision-making layer. Its entire existence boils down to answering one incredibly simple but absolutely crucial question. Given this input, where should this go? The big takeaway here is that a router doesn't actually process your data. It's not reading the deep contents of your file. It's definitely not executing your code. It's just a dispatcher. It glances at the incoming info and says, okay, you need to go over there to get sorted out. It's literally the ultimate digital middleman. Moving to section 2. Let's use a restaurant analogy to really lock this concept in. Picture walking into a busy restaurant. You are the customer, which maps directly to our raw input. Now, the very first person you meet is the host at the front door. This host, that's our router. The host isn't going to cook your food, and they're not even going to take your specific drink order. Their only job is to figure out where you belong and seat you with the right waiter. That waiter is our final destination, or what we call a parser in computing. The waiter is the one who actually understands your specific order and gets the job done. Let's push this analogy just a little bit further. Imagine a customer walks through the doors, rattling off fluent French. The host, our router, hears the French language. Now, the host doesn't need to be fluent in French themselves. They don't need to understand the customer's hyper-specific request for an espresso. They just need to recognize the language on a purely surface level. They hear French, and boom, they instantly route that customer to a table with a French-speaking waiter. The router made a lightning-fast, surface-level decision to get the input to the exact right destination. All right, section 3, how a router actually works under the hood. Literally every single system that handles input follows this exact 3-step pipeline. Step 1, the input arrives. Again, just raw, uninterpreted data. Step 2, the router intercepts it, acting as our trusty dispatcher. And step 3, it gets sent to the parser, or destination, which actually decodes the meaning. The router sits right smack in the middle as the traffic cop. If you yank the router out of the equation, the whole system just collapses, because the raw data has absolutely no clue which program is supposed to read it. Now, this is where it gets super interesting. Look at the difference in what these layers actually know. The router has a broad but very shallow scope. It knows a tiny bit about a whole lot of things. It knows what a JSON file is, what an XML file is, what a web request looks like, but it has zero clue what's actually inside them. Meanwhile, the destination software has a narrow but incredibly deep scope. A JSON parser knows absolutely everything about JSON grammar, but knows completely nothing about XML. The router relies on surface signals just to bridge that gap. Which brings us right to section 4, common routing signals. So just like that restaurant host listening for a French accent, your computer's router is constantly looking for specific metadata. Think about file extensions. If you double-click a file ending in .txt, your operating system's router goes, text file, I'm sending this straight to Notepad. If it sees .exe, it tries to run it. On the web, it's looking at things like HTTP content type headers or network ports like port 80. Every time you click a file or send a request, the router uses these tiny specific clues to instantly know where to dispatch your data. And finally, section 5, when routing goes horribly wrong. We've all been there. A massive, scary red error message pops up on the screen, and for beginners, the immediate thought is usually that the destination software is totally busted. You think, man, my code compiler is broken, or the entire database is down. But I really want you to start asking yourself, is the system actually broken, or did something go sideways before the data even reached the system? Because here's the secret. In so many cases, the system isn't broken at all. What you're actually experiencing is a routing error. That simply means the wrong destination was called. The router followed a bad surface signal and sent your data to the completely wrong place. Like if you hand a perfectly valid Python script to a Rust compiler, that Rust compiler is going to throw a massive error. But is the Rust compiler broken? No way. You just routed Python code to a Rust destination. Let's say you're typing away in your terminal and you want to pull up your Git history. So you mean to type git log, but your brain glitches for a second and you accidentally type docker log. Boom, the system throws an error saying unknown flag. What actually happened here? Well, the router in your command line saw the word Docker and faithfully, flawlessly routed your request straight to the Docker program. But you wanted Git. This is a classic human routing error. You sent the wrong routing signal to your own fingers. The software didn't fail at all. The routing failed. It's exactly like the Postal Service. If you write a beautiful, heartfelt letter in French and the envelope says Paris, France, the postal router delivers it perfectly to a French speaker who loves it. But what if you accidentally write Paris, Texas on that envelope? The postal router still does its job perfectly. It flies it right to Texas, but when the person in Texas opens a letter written entirely in French, they're going to be completely lost. The recipient in Texas isn't broken, the routing signal on the envelope was just wrong. This quote hits the nail on the head. The router is often the real culprit hiding in plain sight. When you're stuck debugging a gnarly problem, it is so tempting to just blame the final destination. It's like blaming the waiter who brought you the wrong food. But if you take a step back and realize that the router is this hidden, silent dispatcher sitting in the middle of the whole shebang, it will honestly save you hours of frustration. Grasping this distinction is what separates people who just blindly use tools from those who truly understand how system architecture works. So here's a thought to take with you. The next time a giant error pops up on your screen, are you going to immediately assume the software is broken? Or will you pause, take a breath, and ask, hey, did the right destination even get called? Keep that single question in your back pocket, and I promise you, it'll completely change the way you look at computing, debugging, and everyday technology. Thanks for hanging out with me for this explainer, and keep asking those deep questions.